Okay, we're gonna get started with those of you who are here. So first things, again, if you are planning on taking the AP Stats exam tomorrow afternoon, you need to complete the exam setup. There's still about half the students in this class who have not completed that step. At this point, it is too late to cancel. Right? Like the last opportunity to cancel, I think, was on Monday. I think. All right. So you need to complete that exam setup before you can take the exam. It must be done by tonight. If you wait to try and do it tomorrow morning, chances are you will not be able to complete it and you will not be able to take the exam. It has to be done the day before. Okay, so please, if you're taking the AP Stats exam, you need to complete the exam setup. Right here. I'm going to share on the screen here, and I apologize for putting people's names out there, but this is where we're at. These things need to be done. If your name's on this list, you are registered to take the AP Stats exam. Your exam has not been canceled, and you should complete the exam setup if you're planning to test. If your name is not on this list, then as far as I can tell, you've completed the exam setup and you're ready to take the test tomorrow. Right? You're ready to do the check-in, essentially, once it becomes available. If you have not taken any other AP exams this semester, you must complete the practice exam before it will show this exam, the AP Stats exam, in your current exams in the testing app. Right? You have to have completed at least one practice exam among all of your AP exams that you're taking in order for your actual exams to show up in your testing part of the testing app. Okay? That's kind of their condition. They want you to have practiced going through the setup and the check-in before making your tests available. So if right now you're set to take AP exams, including this one tomorrow, but you don't have any exams showing up in your My Exams tab, you need to complete the practice exam for at least one of your courses before your courses will show up. Right? Then you need to complete the exam setup. So again, please complete the exam setup. If it is not done by tonight, you will not be able to take your exam. Right. The other thing that goes along with that, even if you're considering like, well, I'm just not going to take the exam, doesn't matter if I didn't cancel, didn't cost me any money. That's all well and good. It didn't, maybe you got a waiver, a fee waiver for your AP exams, right? The issue is just not showing up, is that the school still has to pay for the exam. Right? Now, that's not necessarily an issue to you yourself. However, what ends up happening is that in the future students who would normally qualify for a fee waiver may not get the opportunity because we may not get as many fee waivers because we're not using them. All right, so your actions and your choices could possibly cost another student the opportunity to take an exam at a reduced or no price. So please take that into consideration. And just so you know why we make such a big deal out of this. All right, so again, please do the exam setup so you can have the opportunity to take the AP Stats exam. Other than that, again, grades. I have to post grades for seniors by the end of the day, end of the school day on Friday. if you are a senior, right, grades have to be posted by the end of the school day on Friday. That is your last opportunity to get work turned in, is this week up through the school day on Friday. At the end of that day, I have to finalize my grades for seniors and post them to Synergy, and actually like post them as official grades. Right? That needs to be done so that students who may not have enough credits for graduation are told so, and things can be done about that and such and things. So for all intents and purposes, this is the last class. This is the last time I'll see most of you. It's the last class of the semester for AP Stats. The class itself ends on Friday, and that's it. Right? There is no final. If anyone in here is a junior, there's no final next week. There's nothing I'm going to have you do outside of the things that are already available in Canvas and assigned to do. If you are a junior, you do get that little extra window of time to submit assignments. But that's it. Are there any questions about grades? Again, if your grade is not what you would like it to be, right? If you're not passing the course, especially if you're not passing the course, please do the multiple choice assessments. There's what, 5 of them, 6 of them? 6 of them. All right. You could feasibly get through all 6 of those in about an hour if all you do is guess. If you get more than a 0, your grade will improve. Most minimal amount of effort, you could pass this course. You could get credit for being here. All right. Get credits towards graduation. Get credits so your GPA or anything doesn't suffer as much. Whatever motivation there is. All right. There's no reason to not get credit for this course. So also please consider that. Okay, so then last thing, or what we're actually doing today, we're going to do a little bit more review for the AP Stats exam, as that is tomorrow. And this is our last opportunity to review. We're going to do a Kahoot. So it's a little bit of a, lower stakes kind of easygoing kind of review thing. I did not write this Kahoot. I found it and it's okay, but I'm using it because it's much faster to find one than to create one from scratch. So we're going to do that. So I'm going to get this set up. Give me a moment. All right, so you guys should be able to see the shared screen that has the join code for the Kahoot. All right, so go to www.kahoot.it and put in the game pin. Or if you have the app on your phone, you're more than welcome to use that. And we'll get started in just a few minutes. It looks like I'm up to 9 players in the game, which is half of the class that's in Teams meeting right now. Please join. Even if you're not taking the AP exam, please join the game, do a little bit of review, make it a little more interesting for everybody who's playing. All right, we're gonna get started. So thank you for those of you who are in here. Let me get this going. If a distribution has data mostly on the left with a few points spread far to the right, it is blank. Please make your selection. All right, so it is skewed to the right. The mean is greater than the median. All right, remember, the direction of the skew is the direction of the tail. All right, whichever side the tail of the distribution is at. So in this case, if most of the data is on the left-hand side and there's a few points to the right, we have a skew to the right. The direction of the skew is the direction that the mean is pulled towards. So if the skew is to the right, towards the greater values, then the mean is going to get pulled away from the median and will be greater than the median. All right, we get the one correct answer. Good job, Alexis. All right, next question. Which of the following numbers is not part of the empirical rule? The empirical rule is a fancy name for something that goes along with our standard normal curve, having to do with the proportion of the results or data that are within certain numbers of standard deviations. All right, and 90 is the correct response on that one. The other three values, 68, 95, and 99.7, are all the proportions under the curve for being within 1, 2, or 3 standard deviations of the mean. We have about 68% of our data within 1, 95% within 2, and 99.7% within 3, approximately. 90 does not go along with the empirical rule. All right, we got some more players. So which type of plot best determines whether or not a linear model is appropriate? This has to do with chapter 3. Alrighty, and so the correct answer is a residual plot. These are the plots that basically have a horizontal line representing 0 running through the middle of the graph, and then the points are plotted up above the line or below the line, showing how far away they are from the line that models that distribution, or models that scatter plot, essentially. Right, so the residual plot, as long as it has no obvious patterns, like it doesn't follow a curve, and all the points are basically within the same amount of distance away from that horizontal line, that means a line is a good model for that scatter plot. The other options there, normal probability plot has to do with whether or not a distribution is approximately normal. Right? And a normal probability plot should look linear. And if it is, that means that the distribution is approximately normal. A box plot is that kind of box and whisker plot where you have the box around the IQR and the lines coming out from each side to the minimum and the maximum. Uses the 5-number summary. A stem and leaf plot is a way to represent quantitative data, kind of like a dot plot, but you use the numbers on one side of a stem, or you can do a 2-sided stem and leaf plot where they come out from the middle. Right, we got Alexis still in the lead. Which of the following is an example of qualitative data? Right, not quantitative, qualitative, similar to categorical. Excellent, that would be zip code. Right. The other 3 options are all quantitative data. Those are all things that it would make sense to find the average of. Right. Height, income, and wingspan. Zip code is more of a categorical thing. It is qualitative. Right. It would not make sense to take the average zip code of a sample of people. Think of qualitative as a quality. And Caesar's making a push-up. Next, which of the following is resistant? And when they say resistant, resistant to outliers or extreme values. And that would be the median and IQR. Right. The mean and standard deviation are not resistant. Extreme values or outliers will make significant changes to the mean and standard deviation. Right. The mean and range would also be impacted. Right. The range is not resistant to outliers because the range is essentially how much is between the minimum and the maximum. So if you have an extreme value, that's going to make the range even bigger or smaller if it's on the other side. All right, the median and range. Median is resistant, but range is not. Right, so median and IQR are resistant to outliers, which is why they are typically used when talking about the center and spread of skewed distributions, because they are more reliable. All right, Alexis is still holding on strong, but Caesar has a correct answer streak of 3. Which of the following is part of the 5-number summary? One of these things does not belong. Remember, the 5-number summary is the 5 numbers that are used to make a box plot. Yep. So the median is part, sorry, I misread that. I apologize if I led you astray. The mean is not part of it, the mode is not part of it, and the range is not part of it. Just the median, right? Mean isn't, the average. Average does not come into play when making a 5-number summary. The mode is whatever value happens the most often, right? Which is not necessarily part of that 5-number summary. And the range, well, we can determine the range using a 5-number summary. It is not needed as part of the 5-number summary. Right? 5-number summary is the minimum, first quartile, median, third quartile, and maximum. Those are the 5 numbers of the 5-number summary. What is the formula for finding a residual? How would we determine how far away each point is from a line that models the scatter plot? All right, so this is observed minus expected. All right, Q3 minus Q1 is the interquartile range, the IQR. Right. Observed minus expected, and again, this is in chapter 3 that we recently saw. That tells us how far away a given point in a scatter plot is from the linear model, from that linear regression. And that is what the residual is, right? How far away that point is. And that would be observed minus expected. The other two here, expected minus observed and expected plus observed, are not used anywhere. No movement. Which of the following is not a condition for a geometric distribution? This distribution is very similar to a binomial distribution, except for one condition is not needed. Consider what you're trying to determine with a geometric distribution. All right, so the only one of these 4 conditions that is not needed for a geometric distribution is the fixed number of trials. And that is mainly because you use a geometric distribution and geometric probability to find the number of trials needed to get the first success. A geometric distribution can show the expected number of trials needed, right? So the other 3 conditions are all necessary. These 4 conditions are necessary for a binomial distribution. Right, we need 2 possible outcomes, meaning it's binary. We can either succeed or fail. Probability of success is the same for each trial. That allows us to actually do the calculation. And every trial is independent, meaning knowing what happened in one trial has no effect on the next trial. And the fixed number of trials only applies to a binomial distribution. The geometric, we're trying to find that value. Trying to figure out how many trials it takes. And Caesar takes the lead. And Lorena moved up 5 spots. Good job. A researcher plans to obtain a random sample of heads of households from each of 23 counties. What kind of sampling is this? And this is a stratified sample. Right? This is not necessarily a simple random sample, because a simple random sample would be simply randomly selecting people across all 23 counties without separating them out by each county first. Right? It's not a cluster sample, because in a cluster sample, we would separate each of the 23 counties out and then randomly select which counties would participate in the sample. And then everyone in those selected counties would be in the sample. Right? And the systematic sample would be saying, like, okay, if we label everyone from 1 to 10,000, however many people are in the counties, every third person will be part of the sample. That's a systematic sampling. Right, so this is a stratified sample because they are they're put into strata, the 23 counties, and from each county, we're obtaining a sample. So there's an SRS for each of the 23 counties. A little bit of movement there. Which of the following is not important in the design of a good experiment? Consider, what do we need in a good experiment? All right, so we do not need to replicate the experiment many times. Mostly this comes down to the wording of the question. If I'm replicating an experiment many times, it's already been designed. So that part is not necessarily needed to design the experiment. When we talk about replication within an experiment, when designing an experiment, that's referring to having a sufficiently large amount of subjects, right? So that we have essentially repetition of this thing occurring. Right? We may want to replicate our experiment many times to see if it actually is doing what we think it's doing, but that is not part of the design. And control of confounding variables is absolutely needed. We need to explain how we will control other things that might affect the outcomes that we're measuring so that we get usable data. April's moving up. Which of the following is a parameter? Remember, in this course, we have parameters and statistics. One refers to a population and one refers to a sample. Which of these things refers to the population? All right, and the solution is sigma. Right, sigma is that thing that looks kind of like an O with a tail at the top of it. That represents the population standard deviation. Right, variables and symbols that represent population parameters, right, or like sigma or mu, for example. Right? We have sample statistics. That would be like X bar or P hat. Right, so sigma is a parameter because parameters go with populations, and then statistics go with samples. April's moving up. 3 correct answers in a row. Which of the following is a statistic? So which of the following is used to represent something we know about a sample? Or something we can calculate about a sample? All right, so the correct answer on this one is the standard error of whatever B was representing. And the standard error has to do with the standard deviation of the sample. All right, beta is the population parameter for the slope of the linear regression for the population. Mu is the population mean, and sigma is the population standard deviation. Those 3 things are all parameters. The standard error of B is a statistic as it has to do with the sample. If all other information for a confidence interval is the same except for the confidence level, which is true? Yes, the first option, a 90% confidence interval, is narrower than a 95% confidence interval. Right? As we go to higher percentages for our confidence interval, the interval gets bigger. Right? Consider, like, if I'm 100% confident that my interval contains the actual mean or proportion or whatever, the only way to be 100% confident is if we just include everything. That's very wide. As our confidence interval decreases, as the percentage decreases, the window gets smaller as we become less confident because we're going down to a smaller set of values that might contain what we're looking for. Okay. So a 90% confidence interval will be more narrow than a 95% confidence interval. Andrew's moving up. Which of the following is the conditions check for normality for proportions? Sorry, I know it doesn't say normality, but that's what it means. The key is that we're talking about proportions, not means. All right, and the correct response was choice B and C. If you selected only B or only C, you're only halfway there. All right, option A is the large sample size needed for checking normality of means. So if we're dealing with means or averages, that's the normality condition. All right. for proportions, we need to confirm that the number of successes and the number of failures are both at least 10, which is NP is greater than 10, N is the number of the sample size, and P is the probability of success. 1 minus P is the probability of failure. B and C together is the condition to check, the large counts condition. What is the formula for the lower cutoff for an outlier as defined by a modified box plot? So how do we determine the lower bound for a possible outlier when using the 5-number summary? And the correct answer is Q1, first quartile, minus 1.5 times the interquartile range, or IQR. Anything less than that value would be considered an outlier. And we can also find the upper bound by adding 1.5 times IQR to the third quartile. All right. And it stays the same. The power of the test would be greatest for which sample size n and significance level alpha? Remember, the power of the test is the probability of correctly finding evidence for the alternative hypothesis when the alternative hypothesis is true. Right, and the yellow or third option there is correct. Right. The way to increase the power of a test is to increase the sample size and increase the significance level. One or both of those things will do. Right. Of the 4 options here, that third option, n equals 30 and alpha equals 0.05, pairs the highest sample size within the 4 options here and the highest significance level between the 4 options. So that option would result in the largest power or the greatest power. Right, and Andrew moves into the top 5. In a 4x3 two-way table, the number of degrees of freedom is one of these 4 options. Consider, how do we determine the degrees of freedom when conducting a chi-square test for homogeneity or independence? We have a two-way table. And the answer is 6. All right, remember, to determine the degrees of freedom for a chi-square test of significance, right? We take the number of columns minus 1 and multiply that by the number of rows minus 1. So that would be 4 minus 1 times 3 minus 1, which is 3 times 2, which is 6. So again, when calculating degrees of freedom in a two-way table, is 1 minus, or the number of rows minus 1 times the number of columns minus 1. Given non-empty events A and B, what does it mean when events A and B are mutually exclusive? When it says non-empty, it just means that things are there. All right, and the correct answer is events A and B do not have any common outcomes. When two events are mutually exclusive, that means they have no common outcomes, but it's when one happens, the other one cannot happen. Right? They both can't happen at the same time. That is mutually exclusive. And Britt moves up to third spot. Which is the correct interpretation of a normal probability plot? I alluded to this earlier. All right, and approximately linear, so approximately normal. Yes. So in a normal probability plot, if we get something that is approximately linear or looks like it's a line, that means that the distribution is approximately normal. This is completely different than a linear regression or a scatter plot. It's kind of a scatter plot, but yeah, that's a different explanation. Yes, all right. All right, Brittany moves into the second spot and Andrew moves up to fourth. Last question, what test would you use to see if there is a relationship between GPA and SAT score? This one you might have to guess on. We'll see. All right, so in this case, this has to do with something in chapter 12 that we did not see. This is what happens when I steal things from that are available online. The linear regression t-test is a significance test having to do with linear regression. We didn't get into tests about linear regression because that was in chapter 12. The other three possible tests were tests that we saw in chapter 11, the goodness of fit and independence, and the two-sample t-test was from chapter 10. Right? These tests are not appropriate for finding to see if there's a relationship between GPA and SAT. Yeah. So I apologize for that. This one was kind of a guess. Some of you got it right. April is third. Brittany is second. And Caesar taking in first place right there. Good job. Thank you all for playing. We're gonna end thus. Dead. All right, so that's what I wanted to do for our review today. I don't want to get into anything super intense. That was for yesterday. So again, please, if you're going to be taking the AP Stats exam tomorrow, make sure you complete the exam setup. Also, if you're unhappy with your grade in the course, please continue to get work done. Try to improve your grade. If you need help with that, you have questions about that, make sure you let me know so I can help you and work something out. Other than that, this is essentially the last day of class for period 3 AP Stats. I will not see you guys again. This is our last class meeting. Next week, if you're a junior, next week is finals week. It is asynchronous. You will not be seeing your teachers. And I am not assigning a final to anyone. That's not happening. It's just the things that are assigned in the course already. Those are the things you should be working on. And that's that. I want to thank you all of you who've been here for the year and working hard, for all of your hard work, your perseverance. This year and this course was not at all what we expected it to be, as far as online and distance learning from home, not really being in person that much, and not really getting the time that we would have normally wanted to do this content. So I want to thank you guys for sticking with it, putting in the hard work, showing a tremendous amount of perseverance throughout the whole school year. I know it was very difficult, and I know that your grade in this course and your grade in other courses is not a fair reflection of who you are and who you are as a student. For many of you, there were lots of things throughout the course of this school year that probably didn't go your way, and maybe it wasn't fair to you as a student, and things out of your control that made it very difficult for you to be a student and to give what you normally would have to your classes. And so consider this year as what it was. It's an outlier. Hopefully this is not what classes and things that you do in the future will look like. This is a moment in time. It will get better. Things are getting back to normal, hopefully, with whatever you do after this school year, whether you're graduating, whether you're a junior, whether you're going to college or you're getting a job, or taking a gap year, whatever it is you're deciding to do, that it goes well for you, that you have fun with it, that you find success in whatever you do. I hope you all the best. I wish it could have been different. I wish I could have gotten to actually know a lot of you. And for most of you, I don't really know you guys. I never met some of you at all in person. But I just hope the best for you. I hope that this was an okay experience overall, at least for my course, and that you just, from this point on, you get to, hopefully get to experience things that you want and have success. That's it. That's all I can hope for you guys. So with that, that's the end of the course. That's the end of the class. Have a great rest of your week. Have a great weekend. Have an awesome summer break. Congrats to those of you who are graduating. Enjoy the time with family and friends, and maybe we'll see you around, and take care of yourselves. That's it. That's all I got. I don't know what else to say. That's all I got. Take care.